Right. Scientists use percent of error a lot, and they want their percent of error to be very small because that means they are very close to what something should actually be. And when you're measuring things, that's really important. So in this problem, we have Andre measuring the diameter of a circle, and he said it was 7 centimeters. The actual diameter is 6.7 centimeters. And what was Andre's percent of error? Remember, we're human. We don't measure exactly. He may not have found the exact center of the circle to draw that diameter through. So he's off by a little bit. Well, we want to see how accurate is Andre. So we're going to use that percent of error formula. And that's where we find the error amount by taking the difference of the two numbers, and we're going to divide it by the actual amount, what he should have measured it, and then multiply it by 100 to turn it into a percent. So he measured it to be 7, and we're going to subtract out what it was actually, and then we're going to divide it by the actual, which was 6.7, and then we're going to multiply by 100. So when we take that 7 minus 6.7, we get 0.3. That's how far off he was. He was 0.3 of a centimeter off. But what percent error is that? Because if he was 0.3 centimeters off and it was 100 centimeters, that's not a whole lot. But if it was only 2 centimeters, he would have been significantly off. So we're going to see what percentage that is. So when I take and I divide 0.3 divided by 6.7, I get this nasty number right here, and that's okay. So let's just copy down some of them, and then we're going to multiply it by 100. So times 100, and then we're going to take that and we are going to round it to the nearest tenth. So that would be 4.5%. So that means that Andre's measuring was with an error of 4.5%. So he's pretty close.